Now, if you've ever tried to write old-style integration tests with a database of any kind, you know that it's not fun. There are better ways to do that. And on the show today, I've got Tim Vale to tell us about Testcontainers. Tim is the VP of Solutions Engineering at StarTree, but don't let that title fool you. Tim is a coding VP, my favorite kind. And he's going to talk to us about Testcontainers and Apache Pinot and this emerging better tool set for doing integration-style testing using Docker. Let's listen into the conversation between the two Tims. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and very happy to be joined today in the virtual studio by Tim Vale. Tim is the VP of Solutions Engineering and Enablement. That's quite a cocktail at StarTree.
Tim, it is so good to be here, being interviewed by another Tim, the other Tim. This is exciting.
I think this is going to be a good combination. So we're going to talk today about testing databases. And I think I want to, before we jump in there, I always feel like when I'm talking about technical topics, sometimes I have to explain my title. I just called you a VP of something, and we're talking about testing databases. I just want to reassure everybody, Tim is a VP who codes. That's the best kind. That's literally the best kind.
I sometimes think, Tim, I spend too much time writing software these days. I do. I write a lot of code. I'm pretty active in some open source projects, some things that I do on the side. I like to spend a lot of time writing technology. I can't imagine doing what I do without doing it almost daily, and that's kind of where I am right now.
I've been doing some stuff in the last month that
it's fun.
It's so much fun, and it's useful. And the team is like, wow, he's hands on. That's great. And I think if maybe we all saw how much time, particularly over the last month, I'd put into a couple of projects, maybe that wouldn't necessarily be well loved by everybody in the reporting chain. But
yes, exactly. So we won't share these bits with them. But one thing, and I have made this known to a couple people. I actually submitted and got approved my first pull request to Apache Pinot. I mean, that's kind of the level to which I have sunk in the development world. Here I am supposed to be leading enablement, and I'm secretly submitting pull requests. These are not PRs, sophisticated. Yes, these are not sophisticated PRs, by the way. I don't want anyone to get the impression that I working on the internals
in a comment.
It was only slightly more sophisticated than that, but that's roughly. But nonetheless, I mean, I feel somewhat proud of myself for.
I'm going to go through and look for all of the omitted Oxford commas in comments and open PRs for those. Like, I've contributed to Apache Pinot,
and then both Tims can say they are committers.
Yes. So stand aside.
Yes.
Anyway, you have many interests, but one of them is test containers. Not to bury the lead. And I am old enough to remember writing tests with stubbing and functional test frameworks, and sometimes just no test framework, but let's make sure there's an empty nuke and paved database instance lying around when the tests run code in years past. It's never been good.
No, it's, things have gotten a lot better, obviously, over the last few years. I mean, there's lots of new and interesting technologies that have really changed the way people do testing. But still, it's a bit awkward. And of course, the kind of testing I'm talking about, I mean, and there will be purists out there who will get upset, I suppose, at any definition I give. But, there are, kind of more traditional like unit tests. And in unit testing, of course, there's mocking and all these other things. So we're not necessarily talking about pure unit tests. But at the end of the day, when you're building sophisticated applications at some level, against a database, by the way, at some level, you want the code that you're writing to actually hit, a real and functioning database behind the scenes. And, the ways that really we've been doing that for many, many years aren't as simple or as trivial as ultimately I think they have become with something like test containers. So, I'll give you an example. I want to write some integration test. And, the way that we would do that, or the way that it's been done for a very long time is, if I'm writing it against a cockroach database or a Postgres database or, as we'll talk about, something a little more complicated like Apache Pinot, outside of my IDE, I've got to go fire up, this cluster or this, maybe it's via Docker or Docker Compose, or maybe, I've just got the binary running locally, but I start this thing up and then I run my integration tests and then I close it down. And that's fine, but you kind of have to break out of the IDE to do that work. And to overcome some of those challenges, what you've seen people do is do things like, hey, I'm building my production application against something like Postgres, but just so I can run these tests more effectively, I'm going to do my testing against some embedded database like H2 or SQLite. So you get at this, you get either it becomes super awkward to do, or to make it simple, you end up testing your code against some database that doesn't really look or feel anything like what's in production. And so, while Docker has gone a long way in making this simple, you still end up having to kind of break out of your IDE in order to execute the test. So Testcontainers is this open source project that I can't remember how I came to learn about, but it's something I've really kind of fallen in love with. And what it really does is it is a Java, or at least the way I use it, is a Java wrapper for Docker. And it's built some really wonderful integrations with some of the testing frameworks, some of the more popular application frameworks like Spring. And so that, you're writing a test and essentially you can, annotate that test, or in a before method, or, an at before method, something like that, essentially define a container, a Docker container. And the frameworks themselves will, before executing the test, spin up this Docker container for you, and then close it down. And the beauty of that is, of course, I don't have to worry about going and starting this outside. And this is particularly useful, of course, for like things like automated CI pipelines, where, there isn't really anybody out there to go start this environment for you. So it's this really great way of starting up a Docker container, configuring that Docker container with Java, executing some test against it, and then shutting it down. And so, you get to actually test what it is you're interested in. So I can test an actual Postgres instance, or I can test an actual MySQL or Cockroach or whatever it is.
And this is all in my test code.
It's all
Java
in my test code.
I don't have a YAML file that's defining the images. It's all in like metadata, annotation metadata or something. Or?
Yeah. So, there's, and I can't remember the exact syntax, but, there's, you can annotate, let's say, for example, you're using Spring. Lots of people, of course, use Spring for application development. I come and I annotate my test class with, I think, like at Testcontainers annotation. And then I instantiate essentially at the class level, an instance of it, like a generic container or a Postgres container or something like that. I annotate it with something like a service connection, I think is the annotation. And essentially in the Spring world, Spring understands how to wire all that plumbing. It understands how to initiate that container, initialize that container, run the container during a test, and shut it down.
Nice.
So it makes it super simple. You don't have to go around and do, geez, let me log out here, go to the command line, Docker compose up or start or all this other business. Also, it's something I have really, really enjoyed playing with. It's kind of new to me, but where it gets, I think, particularly interesting is, Docker and by extension, Docker Compose have been awesome for like starting simple services, like, hey, I just want to start up a single instance Postgres or a single instance. That's great. That's easy. But when you start to use Docker Compose for more sophisticated, like distributed systems where the different services as defined in Docker Compose need to speak to each other.
Which you kind of have to do with Pinot, because you've got a broker and a controller and a zookeeper.
Which you have to do, right?
A minion, yeah.
A minion, which, by the way, the naming, I guess
we
could have a whole other pod.
If we're going to talk about naming, there's a component called a server. I like Minion, actually. So Minion's
you're
great.
the Minion naming fan. Yeah.
But we have offline tables, which are nevertheless completely available for queries at all times.
Correct.
Don't get me started. So it's naming things is hard. That's one of the two
naming
hard
things is very hard. So we won't talk about naming.
No.
But yeah, so what ends up happening is, if like the service that, or the the infrastructure that I want to write a test is more complicated than a single instance of something, then like the whole problem gets a lot more complicated. My Docker Compose files look really gross.
Mm-hmm.
And I don't know how much time you've spent with like, trying to orchestrate multiple services in a Docker Compose file that
and
have
get them
dependencies,
talking to each other. Yeah,
get them, and where there's like
I
dependencies.
do demos of Pinot sometimes, and so there's a Kafka, and there are things, and they need to talk to each other, and
they need to talk to each other. And then,
miserable.
if you're doing it really the right way and you don't want to see your logs flooded with warnings or errors, there's an order in which these things start. Zookeeper has to start before this other thing has to start before this other thing. And actually what's interesting and sad in a lot of ways is Docker Compose, like the native ability to really effectively control order and services, it's not quite there. And what you'll see out in the world is lots of ways people have tried to overcome that.
Yeah,
yes,
you get little things you grep for this in a log, and sleep, and I think that's beautiful, Tim. Do you mean you don't like that? You don't like literally grepping for a log and then sleeping for a second and doing that over? Yeah, okay. That's
Tim. These are not things I enjoy.
No, I think I think we can all agree.
Yeah,
I do. Okay, let me stop for a second and say, yeah, that's ugly, and dependencies in Docker Compose is bad and everything, and we do want something better, and I don't want to deny that. I just want to have a little conversation with maybe like 2009 Tim Berglund, who's writing unit tests and kind of exploring what test-driven development means, and kind of. You mentioned the distinction between unit tests and integration tests. You don't want people in the comments going, "Oh, that's not actually an integration." That's not productive. But the stuff we had to do back then, was so terrible.
Yeah,
and testing code that actually, because I mean, unit testing is in my mind almost just a way of kind of exploring ideas. And I think this is sort of the Kent Beck way of doing that. It's a way of asking yourself questions and sort of probing your own ignorance about what it is you're doing.
I totally agree, by the way.
Yeah.
I totally agree.
And integration tests to me are like, okay, now there's this computer program running that with pieces that it touches and it's doing a thing. Does it do the right thing? And it was so bad back then. And even the mess of Docker Compose is glorious by comparison to what we had 15 years ago, but we move on, and it is still pretty messy, and we can do better. So help us with the better.
Yeah. So I think what the nice thing about what Testcontainers allows you to do in this particular case, because of the dependencies, because it's still a little bit difficult to properly organize and order service starting and service dependencies. What Docker Compose or what Testcontainers allows you to do, because it's a Java API, right? And because it follows some really nice, things like the builder pattern, the kind of these more fluent APIs, what you can effectively do is, when you're instantiating a container in Docker Compose in Java, through this pattern, you can define different strategies for waiting. For, in other words, in a much more, I think, fluent and readable and understandable way, describe what it's going to take for this individual container to notify the rest of the world that not the container has simply started, but the container is ready to accept requests. And you can do this in Java. And there's a whole bunch of different strategies, kind of default strategies Testcontainers provides that you can, configure. And then obviously things like the more kind of simplified, which is what Compose does, obviously through YAML, like the depends on. So anyway, you get this much more expressive language in Docker or in Testcontainers to describe, how these different services need to interact with each other before you can declare that the entire configuration, the entire cluster, the entire set of services is really ready to run. And I think that's one of the most powerful things. Again, Testcontainers may be not super interesting if I have just one thing required in order to test a database. But if I've got to, as we do with Apache Pinot, start Zookeeper, start a broker, start a controller, start a server, maybe I want to test some real-time ingestion as we kind of briefly mentioned, real time, and I want to start Kafka and its dependencies, doing this all via YAML and and correctly and appropriately defining the order of those services becomes challenging. Test Containers, I think, does a wonderful job of providing this very fluent, very easy to understand Java API to organize all of these services.
So in this sense, it's a better Docker Compose than Docker Compose that frees you from YAML and replaces it with the Java builder pattern.
I kind of think so.
Bruno Borges, call your office. I don't know if you know Bruno.
I don't.
For years, has on Twitter inveighed against the depredations of YAML, and it was a couple of years ago. He was more actively on this kick, but YAML has a lot not to recommend it.
But since you put us in the Wayback Machine, let us again venture way back to 2009.
Yeah.
What was the alternative then?
Well, that's the thing. And I maybe I need to have Bruno on the show to talk about this. He straightforwardly makes the positive argument for XML over YAML.
Oh, he does?
He does. And it's you listen to him and you're like,
okay.
I don't like looking at XML, but I can't. It's hard to win the argument.
Okay.
Well, it's tough. So
there are lots of things that I in technology that I'm probably passionate about and would cause an uproar by stating out loud. I don't know that YAML its positives or negatives is one of the things that I care deeply about. But I will agree with that statement that like looking at very large XML files, I think there were times where my eyes would bleed.
Yeah,
like I'd be sitting in front of the computer, my eyes would be bleeding.
The argument is more around tooling and things that work better and little hidden. Anyway, we have a separate episode on why YAML is terrible. We get the builder pattern in Java with test containers.
Yes,
and let's go there, and that gives you this platform for writing integration tests against, in our case, Apache Pinot, and in the case of other infrastructure components.
Yeah, and so one of the kind of the interesting things that what I've started to do with it is, so Test Containers has this interface essentially, which is, it's called startable, right? And so it's just something that can be started and can be stopped, but it doesn't really define what that is. And so, for example, one of the things I'm starting to do in a lot of the projects that I'm working on is I have this like Apache Pinot cluster class file that implements startable. And what does it do? I mean, its start method doesn't just start. Well, of course, there is no one thing, right? So what it does is it defines the components required to have a fully functional and working Pinot cluster. So it defines what, in this case, let's say I'm looking at it right now, 4 different Docker containers: Zookeeper, the controller, the Pinot broker, and the server, right? It defines what those components are. It configures each of those containers like you would in YAML and Docker Compose. Is there some additional memory setting? What is the network that I'm using? What ports am I exposing? All of this good stuff. One of the interesting other things that I kind of like about it is it has some better tooling around like getting the logs. So in this particular case, what I do, because it's all going to be in Java and it's going to be, alongside my unit tests, I define like a SLF for J log consumer, so that, it's going and getting all the logs from this individual container and it's dumping them in SLF for J, which then I'm using, some implementation to view in the console. But anyway,
600 possible.
One of the 600 logging implementations.
Every couple of years, there's a new wrapper, and yeah.
By the way, that's a whole other topic. By the way, we could spend an hour on like how badly logging is configured in, generically speaking, like open source projects, but just in general everywhere. Yeah. Anyway, so this class Apache Pinot cluster, I'm passing in like a version, like into the constructor. It sets up all of these containers that are required for Pinot, and then the start method simply leverages the definition I've used for these different weighting strategies and starts the cluster again in the appropriate order, the appropriate wait time. And I for folks listening who don't have a lot of experience, this may sound like, oh, duh, this is super easy to do. Why is this exciting? But it's not just about the container starting. It's about the container being ready to actually accept requests from the next container that needs to start. So we handle all of that. And then the start method, boom, starts all these services. So now when I go do integration tests, right, if I want to build an application against something like Apache Pinot, and I want to start to write integration tests, all I have to do is define this class Apache Pinot cluster, or inject this class Apache Pinot cluster into my test case, and the whole thing is taken care of.
Okay, that's the Spring integration.
That's the Spring integration, but you could do this outside of Spring. But essentially, yes. I mean, it would
now it's an annotation.
Now it's an annotation, or if I were just using like something like JUnit and I was doing it directly, maybe I do a before, whatever the exact syntax is for, or annotations are for JUnit specifically. But yeah, I essentially have encapsulated the entire configuration necessary to start up a Pinot cluster in a single class that then I just go start and I stop, and it comes up very fast. Obviously, it's all in Docker. It's all local. And now I'm not guessing what my application might look like as I run it against Pinot. I'm not having to worry about spinning it up on some more complicated distant infrastructure. It's all right here. It's all local, and it's super easy. It's amazing.
It sounds pretty good.
Tim, it's great.
Yeah.
You would love it.
Okay.
I love it. Tims love these kinds of things.
Tims love these kinds. I should write more tests. I should write more Java. I've been kind of in
what have you done?
JavaScript,
what have you done to yourself?
Python, and I was admonished by another friend who had words for Python, and he said you should have written that in Kotlin. And I think
Kotlin's like kind of taken off. I mean, it's kind of taken off. I think it has taken off.
It has. And there's so much more than just its JVM version too. It's become this interesting multi-platform thing.
I am such a fan of, and I know we're getting slightly off topic here, but I'm such a fan of the work that the folks at JetBrains do.
Yeah.
Their IDs, IntelliJ, and I use DataGrip a lot for database stuff, which is one of their commercial database offerings. Is fantastic stuff. And and I know they're I think they were the creators of Kotlin. And so, every time I install a new version and I read their release notes, it's like Kotlin this, Kotlin that. I'm like, I got to try this stuff, but I just haven't gotten to it.
All right. Yeah. You'll get a chance. If you're spending time writing code, remember, in the world of ChatGPT, when you don't quite know how to write the code, you can get a good rough draft for pretty much free.
Yes, you can.
If we want an example or want to learn more, do you have anything up on GitHub or anything written up on Pinot and
it's a great question. And I am working through a whole bunch of examples that will ultimately be a public GitHub project. I think it's private right now because I haven't quite finished the README. But yes, I've got all of what I just described right now in GitHub. I need to write, maybe by the time this airs, there will be a link available that I can send you with some simple examples of how to use test containers to start up.
So folks, look in the show notes, and if the link is there, you'll know Tim made it happen. And if not, well then.
Well, Tim, as you well know, sometimes getting me to make things happen is a more difficult prospect than I wish it were. But
it might be a hasty generalization to say from 2 Tim data points that this is a Tim property. But as far as we know, it is.
I think all Tims have this issue. I know these two do. But yes, I do like to do these kinds of things and make them available on GitHub. And so it is a GitHub repo. I think it's private now, or at least it may even be a public one, but it doesn't have a decent README. So I will correct that and get that out there. But yeah, it's really fascinating stuff. So if you're interested in building apps against Pinot, which I think you should be, doing something like test containers to start and stop a Pinot cluster, I think is a wonderful way to do it. And by the way, one thing that I've been exploring, which is a little bit taking test containers maybe one step too far. I mean, we talk a lot about it in the context of integration tests, but it becomes such an interesting way to describe and define a cluster of services that I've been exploring using it outside of the scope or context of integration tests. So just in general, using it to start a complex set of services. And while I think that the folks at Test Containers recognize that this is certainly something possible, I'm not sure they're they're out there running around saying, hey, go do this. But I'm actually starting to explore using test containers kind of as an alternative.
The rejection of YAML. And here's your
full
Kotlin
rejection.
Angle. You just throw that in a little .kts file, kscript, boom.
Okay.
Yeah.
Okay.
That just happened.
See, now I will have yet another thing to look at. But yeah, I really like this idea of starting to use test containers Java API for Docker essentially as a way to define, these more sophisticated clusters of services, and using that as a way to start these things instead of having to do it all in Compose. Where that ends, I don't know, but I've definitely started to play with that. And it's pretty neat. Again, it's hard, man, doing these things. Getting all these services to talk to each other in the right order is harder than it should be. So this is a neat way of solving that problem.
My guest today has been Tim Vail. Tim, thanks for being a part of the Real-Time Analytics Podcast.
Love it. Thanks, Tim.
And there you have it. If you feel compelled to help us spread the word and grow the Real-Time Analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.